Laser cutting materials. Which are the materials that you can cut using a laser? Every material behaves differently when processed under a laser. While some are safe to be cut under a laser, others release toxic fumes and are prone to catching fire. Therefore, it is important to understand the behavior of different materials and identify the optimal parameters for laser cutting them. This video provides a detailed guide on laser cutting materials by discussing the optimal parameters for each material and things to consider when laser cutting these materials. Laser cutting wood. Wood is one of the most popular materials for laser cutting and engraving projects. Best wood for laser cutting. Hardwood. Difficult to laser cut, but produces high contrast engravings. Softwood. Easy to cut and produces engravings with low contrast. Plywood. Easy to cut, but can produce harmful fumes during laser cutting. MDF. Easy to cut and engrave but produces harmful fumes. Some of the best wood for laser cutting and engraving applications include balsa, alder, basswood, poplar, cedar, pine, cherry, walnut, birch, maple, mahogany, and oak. Softwood like balsa, alder, pine, etc., have a comparatively lower fiber density than hardwood and produce less smoke during laser cutting. Whereas hardwood like cherry, walnut, oak, etc., has high fiber density and produces heavy smoke during laser cutting or engraving. On the other hand, engineered wood like plywood and MDF are comparatively easier to process under a laser. However, these engineered wood consists of adhesive and other chemicals that can generate toxic fumes when processed under a laser. Laser cutting plastic. Plastics are synthetic materials that release harmful fumes when processed under a laser. CO2 laser with a power rating of over 40 watts is recommended for small-scale laser cutting plastic applications. Best plastic for laser cutting. Acrylic. Laser cutting excellent. Laser engraving, marking excellent. Safety. No harmful fumes. Fluoropolymers. Laser cutting good. Laser engraving, marking good. Safety. No harmful fumes. Delrin. Laser cutting good. Laser engraving, marking fair. Safety. Produces fumes of formaldehyde. Polycarbonate. Laser cutting poor. Laser engraving, marking fair. Safety. Produces heavy smoke when cut. Mylar. Laser cutting good. Laser engraving, marking fair. Safety. No harmful fumes. Polyimide. Laser cutting poor. Laser engraving, marking poor. Safety. No harmful fumes. Laser cutting metals. Laser cutting metal requires high-powered lasers that can generate enough heat to melt and vaporize the metal. These high-powered lasers are mostly found in industrial laser cutters that can cut, engrave, and mark almost any metal. Generally, a laser power of over 1 kilowatt is recommended for metal cutting applications, but a 500 watts laser can also be used to perform clean cuts in thin workpieces. When comparing fiber laser with CO2 laser, fiber lasers can cut thin metal faster, but as the thickness of the workpiece increases, a CO2 laser produces better quality cuts with a smooth surface finish. A diode laser can also be used to make clean cuts in metal, but their low power output limits them to only marking, engraving, and etching applications. Laser cutting paper. Paper is one of the easiest materials to cut by a laser. However, it is prone to catching fire, resulting in charred edges with a brownish hue, which can be minimized by setting optimal parameters and establishing good process control. Generally, a laser power of around 10 watts with low pressure air assist and a good exhaust system is recommended for laser cutting paper. Lasers can be used for cutting and engraving different types of paper, like copy paper, cardstock, 2-ply paper, cardboard, and corrugated cardboard. Although all types of paper are relatively easy to laser cut, engrave, corrugated cardboard can throw up some challenges during the laser cutting process. Its corrugated design entraps the smoke between the layers of cardboard and disperses the laser beam, thereby reducing the ability of the laser to perform a clean cut. Therefore, when laser cutting corrugated cardboard, it is recommended to use a comparatively higher laser power with dot mode setting to reduce heat accumulation in a localized area. Laser cutting fabric. Fabrics are generally soft and require low-powered lasers to cut or engrave. Depending on the type of fabric, laser engraving can result in light or dark marks with variable contrast. Moreover, synthetic fabrics produce a sealed edge when processed under a laser. In contrast, natural fabrics like cotton, denim, etc., produce frayed edges that might require secondary operations to have a clean edge. Generally, a 40 watts CO2 laser is best suitable for industrial applications, and a 10 watts diode laser can be used for DIY projects. Laser cutting leather. Leather is a popular material used in the fashion industry for making various accessories, and laser cutting leather provides a quick and precise way of making intricate cuts in leather workpieces. There are various types of natural and synthetic leather that can be safely processed under a laser. However, synthetic leathers containing vinyl content are not recommended to be laser cut or engraved as they release toxic fumes that can harm the operator and the laser equipment. Generally, a 40 watts CO2 laser with low pressure air assist and a quality exhaust system will produce the best results for laser cutting leather with minimal edge burns. Laser cutting glass. Glass is a tough material that can throw up various challenges during laser cutting. Its brittle nature makes it prone to internal fractures when subjected to the extreme heat of laser cutting. However, using a damp paper towel to cover the cutting area will overcome this issue and minimize the risk of internal fractures. Apart from that, being a transparent material, laser cutting glass cannot be achieved by diode or fiber laser, as these lasers will pass through the transparent surface without producing any significant effect. However, you can apply black paint on the surface of the workpiece to use a diode laser for laser etching or engraving glass. Generally, a CO2 laser with a power rating of around 80 watts is recommended for the industrial application of laser cutting glass, whereas a low-powered laser, around 30 watts, can be used for etching or engraving.